Thank you everyone for coming to my talk. It's called So You've Outgrown Your Monolith. It's a bit of a story of the evolution of the big monolith that serves the API traffic at Stripe, how we decided when it was time to move on and pay down some of that tech debt, and where that project went afterwards. So this is a project that evolved over several years at Stripe. I'm not going to be able to get into everything, but I'll try and do it justice over the next 25 minutes or so, and hopefully share some of the important learnings with you all. Cool. So goals of this talk that I'd love to get through. So in this talk, I want to talk about how we knew it was time to break up our monolith and how potentially in your own organizations you might know that it's time to move on. I am actually a big monolith advocate, especially early on in a company's history. It simplifies a bunch of things, but there is a point in the life where you may grow out of that. And the first question I'll try and answer is, when do you know that it's time? Number two, it's how do you advocate for the work that it's going to take? Having a monolith for as long as we did was kind of just the continual accumulation of some technical debt. And it's going to have to be paid down by someone at some point. And so you need to be able to advocate to engineering leadership, like, why is now the time? And are we going to do that at the expense of potentially some other feature work? And then finally, how do you pull it off? I'll talk about what we called Project Skywalker at Stripe, which was our attempt to detangle the monolith and split it up into smaller services. I won't be able to get deep into the technical details there during this talk, but we will have blog posts and other more deeply technical talks at some point about that project. So just quick introductions. You heard a little bit about me, but professionally, I'm a staff engineer at Stripe. I joined their developer productivity team back in 2018. I did a bunch of stuff in the general developer productivity and infrastructure space, and then I became the tech lead of developer infrastructure in 2021. Developer infrastructure is a superset of developer productivity. So we still have developer productivity, which builds all of the tools, SDKs, IDEs, remote developer environments that we use at Stripe. But we also have corporate technology, compliance, and observability as subteams as well. Generally, the thing that kind of glues all those teams together is trying to get as much of like the non-product building stuff out of the way of making great products at Stripe, so engineers can kind of focus on that. Bit about Stripe. So if you don't know about Stripe already, we're a payments processor. We process payments in about 50 countries, employ about 7,000 people around the world, and about $1 trillion was processed through Stripe in 2023. So that's kind of the big scale of financial infrastructure that we're in charge of. And a bit about the monolith, which we call BAPI. I believe the B in BAPI just stands for big. It serves around 500 million API requests every day. It's built in Ruby. About 13 million lines of Ruby. Not all of that is loaded at the same time, but you know, a lot of it actually is loaded into BAPI. And we did about 6,000 deployments back in 2022. Like a lot of numbers in this talk, that grows kind of exponentially. So I think the 2024 number is quite a bit bigger than that. Other fun fact about our monolith is if you were to try and run the test suite for it end-to-end on a single CPU, it would take you somewhere between 50 and 60 days. Obviously, we don't do that. We take advantage of a selection of our tests in parallelism, so we try and get your results in somewhere between 7 to 10 minutes instead. OK, how did you know it's time to break up your monolith? Or how did we know it was time to break up our monolith? So here is a growth of the number of lines of code in our monolith over time. There's actually nothing wrong with this chart necessarily. Like, you know, your number of lines of code you have in your repository are going to grow over time. But if you have a sufficiently entangled code base, and we did historically at Stripe, you're going to find that a lot of other graphs in your engineering organization grow in the exact same manner, and that's a little bit harder to deal with. So here's another graph. This is the growth of CPU time that we spend running CI for that monolith. And as I said, follows a similar sort of shape. Now, this one is a bit more untenable because this is kind of like also like money that we might be paying to Amazon in order to run these tests or something like that. And so this graph doesn't just grow like this forever. Actually, what happens sometimes is we decide to throw a bunch of really smart people at the problem of this line growing, and the line will go down again. And so we'll like panic a bit and say, you know, I really don't want to buy that many CPUs on the spot market from Amazon, so we should go and do some work. We should, you know, go and profile and optimize that code. And you'll get like a sharp downward sawtooth in the graph. However, you will lose. One-time interventions will not save you from an exponential growth. And so it will go back up again. And then you will panic. And you will send some engineers at the problem. And it will go back down again. And then you will really lose, and it will go way higher than it was before, because, as I said, the exponentials do eventually take over and win. So we saw this in a bunch of different systems at Stripe. It wasn't just CPU time in CI. So here, we've got the number of constants that you load once you do a restart of the monolith after a deploy. Here, we've got the time it takes you to run git status in our mono repo. And here, we've got the number of tests that you will run in a CI build. At some point, we did build a pretty cool test selection system. I think there is a public blog post about that one. But once again, even though you've got the steep downward, you can see where that line's going. And so really what we learned is you can't perform what we call heroics forever. Eventually, you'll run out of cool hacks and low-hanging fruit, and the natural growth rate of a repository is going to win. And also, even if you could try and do heroics forever, there's just very little leverage in heroics, right? The kind of optimization that you do in your Git config is not going to help you with your CI time, and vice versa. So at some point, you need to start considering more fundamental architectural changes to how you write code. Also, it's not just about exponential growth of charts. There are more qualitative things that you can't necessarily chart, and people are going to start mentioning those in surveys if you're listening to them. And so we had what we used to call spooky action at a distance. So people would be like, oh, I'm just going to go change this one file in my team's local code base, and then you run CI, and 7 completely unrelated tests fail, and you're like, how did that happen? It's because someone was depending on some code that they probably shouldn't have, that you weren't expecting them to. And that leads to cognitive overhead, right? You now have to kind of try and keep a bunch of state that is completely unrelated to the feature that you're working on in your head to make sure that you don't break some assumption that someone has made about some code that you've written. And what that results in is just slower shipping. And now at Stripe, in addition to being obviously fast and reliable, one of the things that our customers really care about is our ability to ship new features, to ship new products. And we realized that if we carried on with that general trend of all of that growth, that we were not going to be able to ship at the same rapid clip that we'd been able to historically, and that was just going to be untenable for the business. So we kind of decided at that point, at least within developer infrastructure, within Ruby infrastructure, the teams that were responsible for the code base and for BAPI, that it was time to break up the monolith. And so, what's next? So first, we wanted to talk about concretizing some of our technical goals. And we had 2 concrete technical goals in mind. One was tackle what we call the ball of mud. I'll talk about that in a second. So that was about modularity, making sure that there were boundaries between code in our repository. And then 2, once we had a modular code base, it was about splitting that monolith up into services. It doesn't make a bunch of sense to try and split up your monolith without actually having a somewhat modular code base, because then you just have a gigantic mess, but with RPCs in the middle. So we want to tackle what we called our ball of mud. The ball of mud is the largest strongly connected component of Ruby files in our dependency graph. And so a strongly connected component is kind of just all of the files within the ball of mud depended in some way on all of the other files within the ball of mud. And just because of the way that we dealt with loading code in our repository, that meant that if you loaded or touched one of those files, you were going to load all of those files. And that was also similarly in CI. If you touched anything that interfaced with one of those files, you were going to run tests that were implicated by all of those files. And this was a huge chunk of our repository that was in what we called the ball of mud. And so we knew that we had to shrink the size of this strongly connected component in order to get any benefits of splitting up our monolith into services. Then separately, we wanted to turn from what we had, big API default, going to BAPI, into what we called baplings, which are much smaller, cuter versions of BAPI that only serve subsets of API endpoints. And so we wanted to go to teams and say, hey, you own a single product. You should be able to, if you want to, extract the endpoints relevant to your product out into a separate service, and you can choose your own deployment strategy, your own scaling, your own alerting strategy, kind of separate to everyone else, and move with more autonomy. More importantly, however, technical goals obviously make us feel good as engineers, but more importantly, we need to tie those back to business objectives. What does the business care about? And so firstly, the things that we were hoping to gain was to give engineers the ability to iterate faster. Loading less code on engineers' dev boxes and in CI meant the development loop was going to be faster. Services loading code outside of the ball of mud just run fewer tests. They load way faster. And also, there was going to be less cognitive overhead in developing inside of those smaller services. 2, we could reduce our API running costs. Obviously, costs are important to the business. We wanted to be able to bin pack our API workers more tightly. Previously, we were limited by the amount of memory that we had on a single host, because loading that much Ruby code can take several gigabytes of memory. A Bapling is much smaller. You can pack them a hell of a lot tighter on a single box. Finally, improving API latency. Ruby is a very productive language to write code in, but it's not necessarily known for its execution speed. A lot of that speed is down to garbage collection, and garbage collection is going to run slower over really large heaps. And you end up with a really large heap if you load a bunch of Ruby code that you're not actually going to use into the memory of your process. And so what we found out is once we started detangling some of these services, that we were getting much, much faster garbage collection times, and at the tail end of latencies, that really started to matter for us, and obviously for our users of our API. Finally, after we had some kind of concrete goals, we had to decide between working models. There is a centralized working model in which us, people on developer infrastructure, were responsible for actually doing the detangling work. So we would be able to do the code mods. There's a lot less political complexity in doing that. There's a lot more timeline certainty, but it is quite a bit harder to pull off because you're going to be touching a lot of code that you don't own, and it's completely unrelated to you, and you have to figure out how you're going to be able to do that safely. The alternative is to kind of distribute that work, right? Like, we build tooling, we build runbooks, and then we say, you know, it's your problem now, you own this, own this package, and so we distribute that work to the teams who own the code, file Jira tickets, etc. Much, much harder to predict anything timeline-wise with that one. You can easily get your work deprioritized, descoped, absolutely not done. And if other people are dependent on that work, you're going to be potentially in a sticky situation. So for that reason, because we wanted to be able to give the organization some kind of idea about when we planned on delivering value with this project, we decided to go down that centralized model. When we needed to, we would engage teams to ask them, like, hey, how do we make this change safely? How do we test that? Are you OK with us moving your code or modifying your code in this way? But fundamentally, all of the staffing from this project came within developer infrastructure or very closely related teams. So a little bit about actually making it happen. We kicked off what we called Project Skywalker internally. So Skywalker was the project that was supposed to bring that step function improvement to efficiency, productivity, and reliability by detangling some of our existing Ruby product implementations. As I said, won't be able to get into all the nitty-gritty details, but I do want to share just a couple of, I think, what were the most important parts of this particular project succeeding. So first off, we started small. We wanted to, we started with a gigantic monolith and a deeply entangled code base. Actually so entangled that there were things that had nothing to do with payments that would accidentally pull in code in that ball of mud that I was talking about, because maybe they would share some middleware and there would just be some weird transitive dependency in there. So first of all, we had to prove that something completely unrelated to the payments business of Stripe could be safely extricated from that ball of mud. And so we picked CI-bot, which is our Ruby service that basically orchestrates our builds and does code review and stuff like that. And so we showed, hey, if CI-bot can go from loading approximately the world to loading very little code, then we decided to take on a scary core component. So this was something that actually did handle or was implicated in the taking of payments at Stripe, but was not necessarily a huge component. So we chose what was called the merchant model. So that's kind of almost like the customer model at Stripe. If we prove that we can detangle that, suddenly a lot of other things that follow on from that become a lot more tractable. Then finally, once we had the merchant model detangled, which was just a proof of concept, payment stuff doesn't have to depend on all the other payment stuff at Stripe, we took on larger slices of the code base in collaboration with some of the teams that owned those slices. And so we still did all of the actual breaking up, refactoring of the code ourselves as a team, but we had a partner team that was actually invested in the outcome. They really, really wanted their own services. They really, really wanted to be able to move autonomously, to bounce ideas off, and to vet scary changes with. And occasionally we'd actually ask them, how much does the API need to return this value? Because it seems that no customer has actually used it, and it would simplify our work massively if it didn't. And having a customer team alongside you meant that they could actually just be like, yep, sure, that's not that important. So we had this strategy of progressively riskier de-risking of the project. 2, we made a huge body of knowledge that can be reused by anyone. So this is the Skywalker page on our internal documentation platform. Basically, as the project demonstrates success, we we're getting more and more investment from teams from teams inside developer infrastructure, but also interest from teams around the company. And having this body of knowledge meant we had a way that we could harness that enthusiasm and channel people towards helping assist us with the project. Because there's a lot of parallelizable work when you have 13 million lines of code and a bunch of packages. We can point people in different areas and be like, hey, you could help. And then they'll be like, how? And so we can point them at this and be like, well, why don't you go and fix some usages of this pattern? So we had these set of playbooks, we had an active Slack channel, and people could just follow along and get involved. And so it's super important for us to just have that reusable body of knowledge. Preventing regressions, it is much easier to entangle code in a repository than it is to detangle code in a repository. And so we needed to have a set of ratchets that basically would allow us to say, like, this file should never depend on this file, this pattern is now banned, and all of these things would require explicit override approval from someone who was working on the detangling project in order for you to regress in a specific way. We also built out a packaging system that made it easy to express which Ruby packages you wanted to import and export, and a bunch of visibility rules, so that people could now start to create net new packages that couldn't accidentally be depended on by someone else. And so we wanted people to be intentional about what they were importing and what they were exporting. So yeah, this is internal documentation page of kind of our packaging system that we now force people to use. And then finally, something that was super important to the success of this project was figuring out how to keep up the momentum. Like, any project in which you're paying down technical debt is going to be a slog. And so you need to figure out how you're going to celebrate the wins along the way. So we kind of had a couple strategies to celebrate some small wins. And so one kind of fun one was in the Slack channel that people use to follow along with the Skywalker project. We have a set of Pokemon emoji, and all Pokemon have a number, if you didn't know, that is associated with them. And so when you manage to cut one edge from the dependency graph, we know how many edges we have left to cut. You get to decrement the Pokemon number for the module that you're working on. And everyone else who's following along in the Slack channel can also see until you finally get to Pokemon number 0. And then everyone kind of goes wild in the crowd. Then we have celebrating the big wins. We have a huge shipped email culture at Stripe. So this means that at the when you finally do detangle, so in this case, we've got a fully detangled API service that runs 2 times faster, and in this case, we got rid of what was called the bowl of spam, which was a huge amount of email code that we've managed to detangle. You send a big shipped email going into more of the technical details so that everyone in the company can kind of see, and once again, get excited and potentially want to join the project as well. Cool. Let's talk a little bit about some of the results that we saw. So detangled service wins. So if you tangle a service, you reduce the amount of code that you load compared to the monolith, compared to BAPI, by about 83%, which gives you about a 30% increase in throughput in terms of API traffic that your service can serve, and 3 times faster reload times on the dev box. And so this is really going from changing a Ruby file to being able to see that change in your browser, getting that loop running 3 times faster. Pretty big win for us. Here is an example of one of the deploys at the end of a detangling. And so I mentioned this briefly before, but the way that our code preloader works is it tries to find all code that is potentially reachable from the entry point of a service. And that's a reachability check. So that means if there is any edge from the entry point to a piece of code, we will load it so that we don't accidentally load that code on an API request, which would potentially either cause some unexpected behavior on the API request or spike latency for one unlucky user. So what that means is once you do cut that final edge, you get these huge drop-offs in your graphs. And so this is a deploy where we went from kind of our steady state of almost 10 gigabytes of memory for this particular service to something in maybe the 1 or 2 gigabytes range or something in that range. Here is the ball of mud, and so this is the percentage of our repository that was made up by the ball of mud. Started at about 26%. The huge downline is that deletion of that email thing, the ball of spam, which contributed a lot to the ball of mud. And now we're down probably less than 14 or 13%. Cool. So just talking a little bit about what's next for us at Stripe in terms of our monolith, just to kind of round off. So Project Skywalker ended somewhat recently because the goal of the project was actually quite tightly scoped. We did not try and bite off more than we could chew by just saying, we're going to absolutely get rid of, we're going to delete the monolith, we're going to get rid of everything, we are going to detangle all the code. We said, we want to take a couple of different products. So we took 3 or 4 different products that we had at Stripe, and we want to give those teams, because they are excited about it, the ability to separate themselves from the ball of mud. We're going to detangle their code for them. We're going to use them as kind of like poster children to be like, your code base could be like this, like your service could be like this. But we wanted there to be like somewhat of a distinct end date to the project, because paying down tech debt can go on forever, so you do need to like call it at some point. But that isn't enough. And so we have a follow-on project that is even more staffed than the original Skywalker project, because what we actually want to do now is kind of tackle some of the scariest parts of our Ruby code base. Actually, some of the teams that we did detangling with and servicification with were some of the newer projects at Stripe, which were like logically distinct from just like accepting credit card payments. So for example, like doing loans or accepting or actually paying money out as opposed to taking money in. But the hardest thing is always the code that was written first, and so we have code that's like almost a decade old at Stripe, which deals with that core accepting credit card payments, and so that is what we're going to detangle next. I think people, especially in leadership, were so excited about what we were showing for these new products that we have at Stripe that they wanted that applied to the thing that makes all the money in some sense. And so we have a follow-on project, and we're going to finish that kind of detangling project, and that's going to have the biggest user-facing impact, the biggest developer productivity improvements of any of the work we've done so far, and none of it obviously would have been possible without, as I said, incrementally showing that progress that we did through Project Skywalker. So I just want to leave off with some takeaways that hopefully you can use in your own tech debt paydown projects at your own organizations. One, keep an eye on the signals that it is time to pay down your tech debt. So for us, we collect a bunch of information, we chart everything. We also look at developer productivity surveys to see how people are feeling. And when people start complaining about things that fundamentally do tie back to the fact that you have all of this technical debt, at some point, there's going to be a blaring alarm going off saying it's probably time. When you do decide it is time, start off small, don't bite off more than you can chew. A massive failure mode of these projects is just being overly ambitious in the initial first estimation, and you will just end up going on forever and potentially wasting a bunch of time. Have clear intermediate milestones, achieve them, and then get more ambitious as you go along. And then finally, celebrate the small wins to keep up momentum. As I said, paying down tech debt is always going to take a really long time, and if you can find ways to keep people engaged as you make the small and big wins, you'll both kind of protect your project, both in the sense of leadership. Leadership will associate your project with like things happening and good things happening, but you'll also keep the engineers that are actually working day to day on what, quite frankly, many times are not super glamorous pull requests or super like glamorous work. It will keep them engaged too. So cool, that's everything from me. That QR code is to the Stripe engineering blog, where we have some cool, interesting blog posts about other stuff that we work on. But yeah, thank you, everyone.